up, guys? Today we are going to solve this question: minimized maximum of product distributed to any sort. Even the title is so big and the description is kind of big. So, I've read the description, I've understood. I hope that I'm just going straightforward what the question want to say. So, guys, what does it tell is that we have n number of shops. So, let's say these are the shops: one, two, and three, four, and six, and we have a list of products. Let's say the length of it is 2, which means we have 2 products, and this is the quantity according to those products. So what the question wants us to is basically distribute these products. Okay, let's say I pick the first product, I just gave it all to this shop 1, and I must be thinking, okay, I should also give the product to shop 1 again. No, but I can't, because the question says that in the first constraint is you can only give one product at most, which means that I can only give product P1 to this, and I cannot give product P2 to the same shop. So that's the question tells. And also, so let's say, okay, according to the question, let's put the 6 over here, distributed. Then, do we have any other product left? No, we don't. So, is it allowed to give zero, none items to all of the shops? Yes, it is allowed. Since in the question, it is also mentioned that after distributing all the products, it is possible that some of the shops have remained left with zero amount of quantities. So, okay, cool. So, this is one of the possible answer. But is this the answer which we want? No. Although out of these number of quantities, this is the maximum, but the question also wants us to find out of all the possibilities the minimum of this maximum. So there is one more possibility which have question itself told us is that if you try to pick 3 as an answer of distribution, 3, then 3, then 3, then 2. Why 2? Because for this total up to 9, these 3 total up to 9, and this plus 2 is 11. So we have used this product. Now we try to distribute this product P2, 333. Now this is one of the answer possibility, and as you can see that out of this maximum 3 of all the possibility, and this comes out to be the minimum. So that's the answer. That's the question 1. Now the question is kind of easy to understand, but the main catch is how do we get to know this value, distributed value? You must be thinking that we're gonna do the average of this, then it's gonna be the minimum of all the possibilities. Yeah, kind of, but not actually, because there are multiple products. There is not a single product. Let's say if you even try, let's say I have one product of one this and we have two product of this. If we try to do average, it is 1.5, and we don't actually give a, what do we say, a broken product to one of the, not half product to this and half product to this. It must be a whole unit. So let's move on. How can we do this? So the answer is going to be in the range of 1 to the maximum of these two values, as you have seen in the previous example which I've shown, in which I just put it 11 over here and then 6 over here. So the answer lies in this range. So you must be thinking that, yeah, sir, we can simply do a linear search and just put it one by one. It is not efficient because we need to find the minimum. So what can we do is we're simply going to do a binary search on that particular array 1 to the max of the value of these two quantities. So let's say I try to find a mid m, which comes out to be, let's just assume 5, since the max is 11. So 1 to 11, let's say it is 5. Now what I can do is I can just pick the product 1 and try to distribute it to first shop, then second shop, and I'm left with one product left. Then after that I try to distribute the product 2 with 5, and then again I'm left with 1, and then 0. So this is also the answer, but still we haven't found the absolute minimum. So right now what you can notice is when I try to pick this number, I can tell that how many shops I can fill. What is that? What does it mean? So let's say if I have m equals to 1, let's just assume this case. So even if we try to distribute this among all the stores, let's say 1, then 1, then 1, then 1, and then 1, and then 1. What? As you can see that even though the mid is this, but we have still left with the product which is, this is remain as 5 and this is remain as 6. So this is not the set of a possible answer. So we can't actually use this number. So how can we determine this? So basically it means that there must be a trick. So yes, there is trick. So let's say we have product this 11. So if I try to do 11 and do a seal division on this by 5, I will get a value of 2 point something. Since I'm doing a seal division, then something will convert this into a 3, if even if a point or it is 1 or whatever. Now if I do the same thing with this 6 and divide it with this mid number, what I can see is I will get something of 1 point and then some values. And after I do the seal operation on it, it's gonna be a 2. So as you can see that the total sum up is 5. Now this 5 number is kinda less than 6, the total number of shops we have. So we can easily determine by just doing this seal division that if we try to pick this m, it's going to tell that it lies in the set of our possible solutions. Now if I do the same thing with 1, it's gonna just come out to be, what do we say, yeah, if it divided by 1, then it's simply the sum of this, and the answer is going to be 17. So basically the 17 is kind of greater than the number of shops which we have. So even if we try to pick this, it's not worth it. This is not a solution. So hope you got it that by doing a simple seal division, we could determine that this is the possible solution. Now we just simply going to iterate over it using a binary search and simply going to find it. So let me just code it up for you so it will be more clear. I'm going to create a function which going to tell that is this number can be in the set of our possible solutions. So let's this, as we have known that we have calculated the mid from the binary search. So what we can do is we can just simply check how many store does it cover. So for q in quantities, and yep, and that we have simply, I have simply shown you the seal answer of it. We do a seal on this thing, mat dot seal. It's going to tell us how many shops this thing can be distributed. So let's say I have this quantity and I have this value m. Yeah. Then after that, I'm going to return store. So if it is less than equal to the number of shops we have, which means that this can be a possible solution. So, but still, our main motive is to find the minimum of it. So I'm gonna set a result of 0, and then we're gonna do a binary search over the array, which I have just shown you that the answer is going to lies in the range of 1 up to where? Up to the max of this quantities. Okay, so cool. So I'm just gonna write it up for you. So it is a max of the quantities. Cool. Now, after this, we're going to do binary search where L is less than equal to R. Then what can we do? If, first of all, we're going to find the mid, it's going to be L plus R, and then simply do a integer division. In Python, we do like this. Then after that, once we find the mid, we're simply going to pass it to our possible solution that we're going to check, is this a possible solution? Maybe or maybe not. If it is true, then yeah, we got our answer, man. Then what we can do? We can simply look to the left of it because we want the minimum value. So we're going to say, right, just move on to the left of the array. Else, maybe it is kind of too small to get the answer. So we're going to move to right side of the array. Cool. In the end, we will be able to get the minimum, what do we say? Minimum distributed value among the maximum possibilities. What the fuck I just said, man. Fuck, 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 fuck. Ha! This. So in the end, that's how we get the result. Now, if I try to run this code, it's most probably will work. As you can see, guys, that's how we do it. Yeah, and it's a pretty efficient solution.